And that's all the answers on the final. No, just joking. All right. Anyway, so that's at the end of every chapter is this little key concepts, key equations, key terms, and of course review exercises. So I didn't see any reason to actually sit down and do that. I thought about actually sitting down and looking through each of these and putting together something, but I'm like, why would I do that? This is already together. It's up to you. If I put something together, you would still have to look at it. So if you want something to look at, there's plenty here. It's crazy. It is crazy. You also have the practice final, which I have keyed up if we want to look at that. Let me think. There was, well, no. All right, we'll see. Does anybody, yeah, I think I will talk about this. There was a problem in chapter 12 that references something called a whispering gallery. Has anybody ever heard of this kind of thing? It sounds creepy.
Right? I think, is that like where if you whisper like in one part and you can hear the whisper on another side of the room?
Yeah, so here's the cool thing. What part do you think that is? It's talking about an ellipse. What point is special in an ellipse?
Those two little dots, that name I can't remember right now.
The foci, right?
Foci, thank you. Yeah.
All right, let me take him away. So if you have one person standing at one focus and somebody else standing at the other focus, the way that the ellipse is set up is when it has anything internally reflects off the walls, they will collect at the other focus. All right, it's a nice physics kind of deal. So these things exist. There's like 3 of them that I know of, and I know there's probably more. I just have never Googled. I know there is definitely at least one in Washington, D.C., and there's some other ones. I don't think they're always called whispering galleries, but I can't remember the other name for them. These are true things. You stand at one focus, you say, hey, what are you doing over there? And then somebody over here is like, oh, I can totally hear them. Holy shit. And then they can hear you too, right? So, and then everybody around you has no idea what's going on. So anyway. So that's a kind of a neat problem. It's related to something that's real. Just in case you read through this, you're like, what the shit's a whispering gallery? Whatever. Okay. Any questions, anything specific questions from any homework ever assigned in this class, even? Or we can do more recent stuff. Or do you guys, you're like, can't I just tune out and then somebody wake me up when this is all over? No. I don't think you'll do well on the final if you're comatose. Maybe. Okay. All right. So all I have planned, I don't have much planned, to be honest. I can pull up the practice final. We can start looking at that if you want to. It's really, 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 really totally up to you what we do tonight and Monday. So if you just want to sit there behind your black box with your name on it, okay. Oh, look at that. I got a question. 57 from 11-2. Bam. All right, let's see what this is. Oh, okay. I like this. Yeah, this one's kind of funky. So what's the question? I will say this. The answer is funky. And you're like, thanks, that's helpful. But did you try to solve it and something weird happened? Number 57? Or did you not try to solve it and you just want to kind of do it together? What's going on? Can you give me something to go on? Oh, here we go. Yeah, it just didn't seem to make sense. Okay. All right, one thing at a time. Hold on. Let's look at this. So everybody look at this problem here. Uh-oh, more chats. I've unleashed the Kraken here. Hold on. Oh, of course. You know there will be. You know there's going to be at least one problem like this on the final. So there are several sections that we didn't have a quiz on. They're not going to be like overrepresented on the final, but they will definitely be on the final. Right. And I'm not going to be able to test you on everything we've done this semester. Holy shit. That would be about a 12-hour final. What exactly will I not include on the final? We'll all find out together. So let me come back to this question. How similar will the final be to the practice final? Will there be word? There will be word problems. I like that. There will be blood. No, there won't be any blood. There shouldn't be. How similar will it be? I don't know, dude. So the idea with the practice final is if you are able to go through it and do all of it with relatively little trouble, you should be fine for the final, right? That does not mean that I'm going to take the practice final and change the numbers. You know, I'm not going to do that, right? But there are certain problems that they're just going to be on there. There's not much more I could do with them. Sort of like the end behavior and the multiplicity at the roots, that kind of problem. You know, there's not much I could do to twist that thing around. It's just going to be on there. Or maybe the asymptotes, finding horizontal asymptotes, vertical asymptotes problem. You know, but all right, that's not very comforting, but oh well. So let's look at this one. Try to do this problem if you have not already. Oh, shit. It's a start. Okay. Yeah, I'm going to give you teacher answers on that kind of question. I'm sorry. It's just the way it is. Yeah, you must know everything. That's all. So 57 kind of quickly becomes obvious something, but not so much if you're not used to this. And that pretty much describes most of us except me. But you have to accept the fact that some of these are not going to have an answer, or they're going to have too many answers. So let's see. First off, let's pick. Has anybody started on 57 yet? Are you guys doing it yet? So that the first step is to pick variables. So I'm going to call this person W. I'm going to call this person F because the letter O is bad for me. And I'm going to call, who's the other person? There, the truck driver. I can call them T pretty safely. Okay. So W, T, F. Seems appropriate. So is everybody with me? You got to define variables, and there's the salaries of those people. So what's one equation that I can set up?
W plus O equals 82,000.
Cool. I used F. You can use O if you want to. That's fine. What was it? 82,000. Good save, Jeff. I forgot which number it was. What's the second equation I can make? So the office manager makes 4,000 more than the truck driver. Bam. Is everybody with me? These are not bad. These set themselves up. They're like one step away from being an equation. And the third equation, the annual salaries of the warehouse manager and the truck driver total 78,000. That's easy. So warehouse manager plus truck driver equals 78,000. Now, all right. I already know this is not going to have a specific answer because, well, all right. But all right. Does somebody have an a suggestion on how to move forward here? Which one of these equations is written in a different way that might kind of give you a clue as to what to do?
For the third equation. Oh.
Say again, sorry.
For the third equation, I made it W equals 78,000 minus T, and then I plugged the second and third equation into the first equation. Because it was like F equals and then.
Oh, I see. Sure. And you made it all in terms of T.
Yeah, and then you get to the end where they're the same.
Yeah. So almost no matter what you do, you're going to get somewhere weird. So what she's saying is not, so you got one equation that is F in terms of T. So she said, oh, if I make, okay, Penn, what? All right. If I make one more equation where it's solved for T, so now I've got this, and now I can put both of these in here, and I've got one equation that only has T. Did I draw the, yes, I did, okay. So that would be, so the first equation now would be W plus F equals 82,000. And of course, what happens when you do that? You get 82,000 equals 82,000, and you go, look what I have proven. No. What does that mean? Whenever we solved an equation before and we got to the point 7 equals 7 or 0 equals 0 or something, what did that mean?
Does it mean there's not enough information to figure it out?
There's not enough information to pin it down. So there are actually an infinite number of solutions. And I want you to realize if these guys together make 82,000, stay with me now. Stay with me. If these guys together make 82,000 and this guy makes 4,000 more than this guy, I already know this. I really want you guys to see that. If these guys together make 82,000 and this guy makes 4,000 more than this other guy, then W and T together make 4,000 less. I already know that. So the third piece of information is not new. So do I have 3 pieces of information? No, but I have 3 unknowns. So of course I'm not going to be able to solve this. Now, did you have to be able to see that in the first place? No. But now do you see why this has no solution? You know, it's got too many solutions really. So it's got no specific solution. It's got an infinite number of solutions. Are you guys okay? Are you guys doing all right over there? Okay. It's just like if I'm trying to solve a murder case and I don't collect enough information, who do I charge? Well, I think it could be one of these 80,000 people over there. Oh, so you don't know. I mean, because I don't have enough information yet to boil it down to a few people, right? Do you guys see what I'm saying? No?
Yeah, that makes sense. Thanks. I was doing that problem and that's what I got, and I wasn't sure if I was right or not.
Yeah, you're right. You just have to remember what that means for equations. And these equations are at a higher dimension. They have 3 unknowns instead of 2. They're in 3rd dimension, but they have the same thing. If you get something equals something and it's true, infinite number of solutions. Now, there's a course you could take further down the line in mathematics where you actually define the geometric properties of the solution. And what do I mean by that? Stay with me real quick. Stay with me. Do you remember when we first did systems of 3 variables? And I said it's like they're each a plane. So maybe one is my back wall, one is the side wall, and one is the ceiling. So solution would be the corner of all 3, right? You guys, is everybody cool with that? So, but what could happen? Couldn't you have one plane, another plane, and then another plane, and they all meet at this line? So there's an infinite number of solutions that run along that line. Does that make sense? Okay, maybe. And that basically is what this is. Okay, that's enough of that. That's enough of that. So that's a good question because the answer is a little freaky. You don't expect it to happen when you're like, it's just talking about freaking warehouse manager salary. Why would it be such a weird? Because it's got 3 things I don't know and it's only got 2 distinct pieces of information. I don't care how simple the stuff is it talks about, you're not going to be able to solve it. All right. Anything else, guys, before I move on? Did I miss any chats? No. Okay. All right. I don't see anything else coming in. So let's do this. Whoa. Let me throw this up here. Bam. Bam. All right. So this is up on the Canvas. I didn't put this version up there with all this room. I don't know why not. I just didn't. Ha 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 ha. Look at all that glorious room. And I blew this bad boy up. So there's some like basic stuff up here, right? But not a bad idea is to go through the book, go through the end of the chapter, scan through the topics and see if anything really doesn't sound familiar. And you can do something similar with the practice final. You can kind of scan through it and just see if anything really does not sound familiar. That might be where you want to go spend some time, right? So my backup plan, if there wasn't a lot of questions, was to just start going through this one by one and just have a good old exciting time. Because again, it's more about what you guys need to be ready for this final. Any other suggestions? Does anyone see anything on here that you want to focus on? Does anyone see anything on here that you want to do other problems like it?
Can you do some of the like natural log problems? Because we haven't done those in a while.
Oh, here, these guys?
Yeah.
All right, so let's take a look. So yeah, we can focus on logarithmic stuff. Dude, all right. Let's see. Oh yeah, Jeff, you can use this one. So this is not a bad idea. This is what I'm talking about. So logarithms, again, you just got to shake the dust off a bit. And this is the hard part about teaching online for me, teaching remotely, is I thought about trying to fit in some quizzes that would cover like big swaths. So like a midterm quiz or something. And I just felt like there were going to be enough quizzes already. But the downfall is there are things you haven't done in a while, right? So that it kind of gets on your shoulders then at the end to use something, to go back over the stuff, to bring it back up in your brain. So what's the idea with this kind of thing? For example, what if I had something a little easier? What if it was log base 3 of 9? What would that be?
3.
No.
2.
2. So we already have 9 divided by 3. I don't need to develop a new symbol for that. So remember, what are logarithms based on? They're based on exponents. So what exponent does 3 need to become 9? It needs a second power. Does that sound familiar? So logarithmic outputs are exponents. Does that sound familiar? So this one, what's log base 3 of 27 then?
3.
That would be 3, right? Because 3 to the third power is 27. What would I have to do then to make it become 1 over 27?
-3.
Yeah. So if I see, especially if the bottom is based on this. So if I saw something like log base 5 of 1/25th, I would say, okay, what if that 1 wasn't there? It would be 2. 5 squared is 25. But then I need to put a negative. That makes it flip. Yay. Is that, do you guys see that? Sort of?
What if it's something that's like not as easy to tell?
So, all right, let me think.
Like where you can't just look at it and say, oh, that's -2. I feel like we've done problems like that before, but I don't remember exactly.
Wait a minute. I'm trying to use the wrong thing to work with it. Here we go. So something like this. Let me put a couple together. And I'll remind you what you can do if you can't remember. You could do the same thing I'm about to do on any problem. So here's one we should be able to do directly, but it's a little bit more difficult. Well, let's see. Maybe we can't do this one together directly. What about log base 8 of 4? So here's what I would do. And then I'll show you kind of a longer way, but a way that will always work. What's log base 8 of 2? Does somebody remember? That one's not bad. What's log base 8 of 2?
Is it 1/3?
Yes. So if the input is bigger than 1, but smaller than the base, that means it's some kind of a root. And what kind of a root do I do to 8 to make it become 2? I do a third root. Let me stop for a minute. Do you guys remember that? Here's a really cool kind of thing. What's log base 2 of 8? That's 3, right? Doesn't 2 cubed is 8, right? Do you guys see something neat? No? Okay. So what I would do for this problem here, is I would say, okay, 1/3 would make it 2, and then 2 squared is 4, and I'm done. Yay! But here's another way to do this problem. All right, let's say we don't know this shit, right? You're like, whatever, Jeff, whatever's good for you, whatever. And so do you know the answer? No. So put X. That's what we always put when we don't know the answer. How do I rewrite this now? How can I rewrite this?
8 to the x equals 4.
And then can't I make the bases the same? Do you remember doing this? 8 and 4 have the same base. 8 is 2 to the third power, and 4 is 2 to the second power. Does this feel familiar at all? So when it seems like, when I say do it by hand and you're like, holy shit, old man, how the hell am I supposed to do this? But you can see that they share a base. You can do this. So now what do I do here? What do I know is true here?
That 3x and 2 have to equal.
Yeah, these have to be equal. In order for this to be equal, 3x has to be 2, and then you get the 2/3 that I got, like a long time ago. But sorry, John. Sorry. So it's this idea of constructing the answer. So if I had log base, what do you got, Jeff? You can do it, buddy. 81 of 27. You can do it like we just did it down there, but I want to show you something. Wouldn't 81 to the 1/4 be 3? Because 4 3s make 81. So 81 to the 1/4 would be 3, but I want it to be 27. So what do I raise 3 to make it 27? The third power. So 81 to the 1/4 is 3, but I want to cube that to make it 27. Now, how does this look the other way? The way that we just did over here. You would say it equals x, because I don't know. Then you would write 81 to the x equals 27. Then you would rewrite it with 3s. Then you would say that these have to be equal to each other, and then you would finally get 3/4. Right? Is that all right? Do you guys remember any of that? Sort of, a little bit. So that's the kind of thing you want to do over the weekend, is just dust off some of these ideas. They should come back to you quicker because you went through it already in the first place. right? You don't have to relearn it. You just have to dredge it back up a bit.
Can you show how you would do problem B, please?
Yes, I'm going to do that next. I'm going to erase some of this stuff though. Here we go. Oh, this is such inefficient erasing. Come on. I want to etch a sketch. All right. Somebody's chatting at me. What are you doing to me? I can't handle too much stuff at once. Are you kidding me? Hold on. Make some room. Get out of here. All right. What's somebody saying? Yes, I will. I think I told you that, right? I'm going to make a solutions video for this. Let me see. Oh, shit. Let me do it over here. All right. What do I do on this one? Well, it's kind of like I'm sorry, go ahead.
Oh, no, I was going to say the first thing that came to my mind was to expand the x squared minus 1.
Oh, how do you mean expanded?
Because x squared minus 1 would be equal to x plus 1 times x minus 1.
Oh, you mean factor it? Okay.
Factor it, yeah, sorry.
There's probably going to be something I'm going to want to do in a minute, but right now there's no. Well, actually, okay, that is an interesting point. The main way you would do this is to get the 2 out of the way, and then you have properties of logarithms, and you can combine these. But to be really honest, I really like what you just said. It's kind of like the way I sometimes would do it, because now what could I do with this?
Isn't there a property where you can, that's the same as just logarithm of x plus 1 plus logarithm of x minus 1?
Yes, but the weird thing you got to remember is there's a minus there.
Yeah,
so
minus
we-
the whole thing. So
Yeah. So if you don't like the way I'm doing this, don't worry, I'm going to do it a different way. But then you have 2 of these minus 1 of these. So you just got, I'm sorry, wrong thing I underlined. This one. So you just got 1 of these minus this other dude plus this guy. So this is not your standard way of doing this. So if you don't like doing this way, don't worry. And then the way I do this real quick is everything that's positive is on the top. Everything that's negative is on the bottom. And I'm done. Yay. Because remember, log A minus log B is log of A over B. Those properties. Do you remember those properties, kids? All right. So Jeff, what's the standard way of doing this problem? I'm glad you asked, Jeff. Get out of there. Go away. Oh my God. There's got to be a quicker way to do this. I want a page-sized eraser. No? Okay. So the kind of the textbook way to do this, see that very first 2? I'm going to bring it back up here. Right? Whenever you have a coefficient, you get it out of the way, because now I know log minus log. How can I rewrite that?
X minus 1 squared over x plus 1, x squared minus 1.
I like it. And this is plus ln x, so that would just get thrown up here. It would just be times that one. I don't know if you guys are cool with that. And then you basically get the same answer because you factor the bottom. The x minus 1 cancels, and the x plus 1 is left down there. Hopefully you guys are cool with that, right? If you factor the bottom, it'll reduce. It's the same answer. Math don't give a shit which way you do it. So you got to remember those logarithmic properties. So that's the correct way to look at this problem. This problem sits on a practice final. I wouldn't worry about the specific problem. I would worry about what it means. It means I have to know my logarithmic properties. That's what it means, right? What about this guy?
I have
Oh,
a
sorry.
question about just the test in general. Are there going to be any problems that require the use of calculator?
That require the use of the calculator? Maybe. Why?
I don't know. Just wondering, like if there'll be any problems where it says like, you know, for this answer, use a calculator or something like that.
Yeah, that's very, very possible.
Okay.
Just like in the homework, there were some problems that you had to use a calculator for, yeah. All right, so what about this guy here? Why is this easier? Let me put something down here. Why is this? What would that be?
That would just be A.
Yeah, because what do these two do? Yeah, they kill each other. Because they're inverse functions of each other. Up here, what's in the way?
The 2.
Stupid 2. So very often when you see a coefficient on a logarithm, you're trying to simplify. Part of it is to get that thing the hell out the way. So now you have a 7 that can attack the log base 7 directly. Shabam. Let me show you a different way to look at this. All right. I really want you guys to get this. When do you multiply exponents? When you have something to an exponent raised to another exponent. Do you guys see how I can rewrite this like that? I'll take that as a yes. And then this dies and you get x squared still. I don't care which way you do it. You got to get a freaking x squared. All right. So that was a good suggestion. What about logarithmic equations? Do I have a logarithmic equation on this bad boy? Might as well stay with this theme. No, but I certainly could. Oh, there's something related to logarithmic stuff. I kind of gave it away there, didn't you, Jeff? Oh, well. What do you do here? Use logarithm. Do you guys remember? Do you guys remember why we do what we do here to solve this?
For this, would you take the log, and is that when it brings down the 2 minus 5x?
The only function we know. The only function we know that will bring a variable power down is a logarithm. That's one of its most basic properties, right? That's the property that would end up being the most important. So if I do take like any log, and I normally use natural log because it's got one less letter than log. So you take the natural log of both sides. You don't multiply both sides by ln. That doesn't make any damn sense. But now that comes down as a property of the log. And I think I told you guys, if you really wanted to, you could replace this with A and replace this with B. They're both just numbers because for some reason, these freak people out and they start doing weird shit. But natural log of 5 is a number. Natural log of 29.6 is a number. They're just numbers. They're going to work just like as if they were just numbers. So I can divide this side by that number. Yay. And, you know, and then I'm a couple steps away. And now I've lost interest in this problem. You're a couple of steps away from getting x by itself. Do you guys see that?
So log is the same thing. You would just, like if you were to use log instead of natural log, you would still bring it down and then divide by the log of 5, or no?
Yeah. Ln of something just means what? And log of something just means what? I love it. You're like, what do you mean, Jeff? So this means the base is 7. How's that? So what does ln mean? This is the base is 7.
It means the base is E, correct?
Yes, the base is E. And what's this one mean?
The base is 10.
Base is 10. So it's kind of silly. What if you use a log? Well, I did use a log, right? Again, don't get me wrong. I'm not coming down on you. It was a good question you asked, but I want you to realize the question actually is not really relevant here. It's a log. I don't care which log you use. It'll work the same way. Why do we use natural log? Because it's one of the 2 logs that's on the face of my calculator. So it's the easiest to get to. Is that all right? You guys all right? And you guys have to get, let me see. I don't know if I've done a very good job of this kind of thing this semester. I think I've tried to do it sometimes, but look at this. Here's my next step. Right? This shit just changes. Add this, subtract that. They just switch. They just switch places. That's so beautiful. And then divide the whole damn thing by 5. And that'll be your exact answer. And then you throw all that shit in the calculator and you get your approximate answer. So what if I gave you a log equation, which is something I could totally do on the final because there are logarithms on this practice final. This is how practice finals work. So what if I ask you log base 3 of x? Oh, that's right, Jeff. Maybe you should make this work. Would that be good? Would you guys appreciate it if this actually worked? Sure. Okay. Okay, that'll work. All right. Yeah, that'll work. Yay. How would I solve that thing? Or how would you solve that thing? So real quick, side note, why is this one much, much easier?
I mean, there's a lot of reasons that make it easier. For one, both of them have the same base, so you can combine them, right? And then also the base is the same as what's on the other side.
Here you go, I changed it. So why is this equation easier?
Oh, the one you just showed?
Yeah, why is this one easier than this one? Because there's
let someone-
only
I don't know, I'll
one
let someone
log.
else answer.
There's only one log, right? So then I just have to do 2 to the 4.7 equals x. Are you guys cool with that? That's just, and then you throw that in your calculator, see what the hell they are. Cool. So how can I take this crap and make it look more like this slightly shinier piece of crap? Do I have a way to get these together into one logarithm?
I think I'm trying to remember. It would turn into log base 3 and then it'd be x times x minus 6.
Yep, because you add powers when you multiply things. Logs are powers. That's why the properties of logarithms are the same as the properties of powers. And now I can do the same exact thing I just did over there. X times x minus 6, Jeff, equals 3 cubed. X squared minus 6x minus 27 equals 0, and you factor and blah, blah, blah. Right? So then you get 9, which is how I made the problem in the first place. And you get -3. Are those both cool? You sure?
Oh, sorry. I'm sorry. I'll mute myself.
Are these both okay?
No, because you can't take the logarithm of a negative number.
Yeah. Do you guys remember? Could you right now sketch out the roughest graph in the world of a logarithm? Just a real quick, just make a logarithm.
Yes.
So the most important aspect of a logarithm would probably be this asymptote here, right? Wah! And then it looks like that. So it looks like an exponential. That's been inverted because that's exactly what the shit a log is. It's the inverse of an exponential. Therefore, they cannot handle negative inputs. Now you have to be really, really careful. Just if I get a negative answer here, it doesn't mean that it can't work. It's the fact that it makes the inside of at least one of these negative. You could get a negative answer that makes neither of the insides negative. Depends on what's the inside. Do you guys? So if I have a function that's based on a square root, could I use this value? I like that question. Of course you can. What about this? Can I? There you go. As long as it doesn't make the inside negative. Even if it does, it could be complex numbers, but you know, I'm not going to complex numbers. Don't worry about it. You guys understand? So people like throw negatives out a little too often, and then they don't throw them out when they're actually trying to construct a shed. And they're like, this side's negative 7 feet long. I'm like, what? I want to see that before I die. I want to see. Maybe that's going to be why I die, because I got too close to the anti-shed. All right. Sorry. Too many rants. All right. So I like that. That's any more logarithmic equations. This is kind of nice if we can stick to one idea at a time. Let me see. I don't think I have anything necessarily related to logarithms somewhere else, do I? know? I like this. Look at this. Fantastically not lazy at all. You're gonna be doing that shit. All right. Yeah, I don't think I have any more logarithmic stuff. No. Okay. Do you guys remember? All right. Any other suggestions? I kind of like this problem here. It's very basic, but it's easy to forget some of it. Domain and range should not be a big deal, right?
Yeah.
And then what about these guys? This shouldn't be a big deal, right? Why is it invertible?
Because it's a one-to-one function.
How can you tell?
The vertical line test, horizontal line test.
Horizontal line test. So it passes the HOLT. It's kind of funny. Why did I ask? I should have put these closer together, but too bad for everybody. Then I ask you to do this. What is the ID on part D?
It's a transformation.
Good. Yeah. So I would take all the points.
Move them to the left by 2.
Left 2. And then
Down 1.
down 1. And then I just retrace. So left 2, down 1. I just move them all over. Blah, blah. Left 2, down 1, blah. And then I would just. Let's see. Use. Oh, I'm sorry. I'm sorry, Nathaniel. I'm not. I remember you asked that question. I forgot to come back to it. So real quick, coming back to logarithms for a hot second. Let's see. How do I want to say this? Well, I mean, here's the thing. What if I had, if I had this, what's the answer? No? What's happening? Anybody? So what I can do is I can actually raise e to both sides, and I get x equals e to the 7. It's not, normally we think the base is e, so e to the 7th equals x, but here's another way to look at it. I raise e to both sides, that cancels that, so I get x equals e to the 7th. Or, I could have, how do you simplify this?
Is it W?
Bam! Yeah, of course, because ln and e are inverses of each other.
So would the same just log? Like, could you put it to the power of 10? Raise it to 10? Okay.
Yeah. In fact, what about, let's log base the square root of pi of the square root of pi to the e.
E?
Yeah. These die, right? Log base an a to a power, whatever the hell a is, cancel each other because they're inverses of each other. Only the a's that work. You can't use 0, for example. Log base 0. Think about that for a minute and then stop. That'll freak you the shit out. What about complex bases, Jeff? No.
Please
Sorry.
no.
I won't do that to you, don't worry. How do I do this problem? How do you do that problem? I know how I do it.
Take the points and then switch x and y.
Yeah. So that is so beautiful because if you just remember inverses switch the x and y, you automatically know that the domain and range switch from a function to its inverse. You automatically know that how do I do it algebraically? I switch the x and y and solve for y. Right? It's so beautiful. It's this idea that's a thread through the whole thing. So for example, this is the point 0, 3, so I would plot the point 3, 0 and so forth. Does that sound familiar? We actually plotted the inverse of exponential before we called it logarithm. So we actually graphed it before we knew what the hell it was, which is always interesting. Oh, let's see here. Anything else jumping out at anybody? How about this stuff? How about synthetic division? Yeah, baby. Remember writing all the possible rational roots?
Everyone's favorite part, synthetic division.
Yeah. Oh, come on. Hopefully you're not being sarcastic. Synthetic is awesome. Synthetic kicks so much ass. Do you know how to factor this? Just looking at it? Does grouping work? No.
Nope.
So synthetic says, I got you, man. Don't worry. I'm here for you. You just got to do a little work. You just got to do a little work first. So what are the possible rational roots of this? Why is it not as bad as it could have been? Because there's a 1 where?
On the highest degree term.
Yeah, there's a 1 there, so it's nowhere near as bad as it could have been. So what are the possible rational roots?
Well, it's positive and negative 1,
Good.
3, and 9.
Beautiful. I love it. So it's just the factors of this. Because I'm assuming it came from something like this. So this number times this number times this number has to be 9. So those numbers could have been, any of them could have been 1 or 3 or 9. So then you just start trying them out, right? How does synthetic division work? Does somebody pick one of these numbers?
3. It's too positive 3.
So we'll put him in the penalty box. And then what do I put to the side here? What do I put here?
All the coefficients.
All the coefficients. This is just like matrices, only not as bad. Just like riding a bike, kids. 1, 3, 8, 24. Can you see I don't even have to do it? Don't even write shit down. I know it's not going to work, right? 1, 3, 8, 24, right? Because you bring it down, you multiply, you add, you multiply, you add, you multiply, you add. You're supposed to end up with 0 if it's going to be something that works. Now let's do it real quick because maybe the results mean something. Shh, Jeff, will you stop it with that? All right. 1, 3, 8, 24, 27, 81, 72. Okay, now this is kind of a dumb result, but does anyone remember what it means if they're all positive?
It's like a ceiling, right? Like, no, it's not going to be a number higher than this.
That's right. Actually, this is a good result. What am I thinking about? So what does that mean is true then?
That it's
What
not
can I
9.
throw out? Sorry?
It's not 9.
It's not 9. So I know it could be plus or minus 1, or it could be -3, and that's it. I've eliminated the possibility that it's 9.
It still could be -9, right?
Oh, yeah. Sorry. -9. Good job, Jeff. So the only thing I killed was 9. And of course, 3 didn't work, so I can kill him. And then, you know, and this kind of problem, I try to give you enough. If I give you a problem that's got a lot of possible answers, I try to let you winnow it down so you're not like taking 30 minutes of your final exam time trying numbers to work in a synthetic and going slowly insane. No, I want your march to insanity to be much faster. On this one, there's not that many to do, right? So anybody else have another suggestion?
1.
1. So let's see, 1, 5, 3, -9. 1, 1, 6, 6. Yeah, that one looks good. 1, get out of there, 1. 1 times 1 is 1. Plus 1 is 6. Times 1 is 6. Plus 6 is 9. Times 1 is 9. Plus it makes it work. So what do I have so far?
X minus 1.
Beautiful.
X squared plus 6x plus 9.
And then this one you can factor easy. So remember, you're going to have multiplicity. So if something does work, you can't throw it out of your list because it could actually show up more than once, right? That's a big mistake people make sometimes is they throw a number out when it works. No, you only throw a number out if it doesn't work. If it works, it could work multiple times. Uchaba. And then that leads into number 8, where we talk about end behavior, we talk about roots, we talk about y-intercept. This is another way for me to say multiplicity, right? How does it behave at the roots is related to its multiplicity. Remember all that? Fantastic. You remember that? You're like, man, why did we stop doing that, Jeff? You can't do that, Jeff, in the middle of doing this. That shouldn't have happened. Is some of this shit? Really, Jeff? Yeah, you crazy person. What a crazy person. All right. Sorry, guys. There's 2 main ways for me to draw on something, and one of them is really dumb right now, and I decided to use it for some of what I did. Oh, well. All right. Let me see. Anything else here for like a last problem for the day? We'll leave the rest of it for Monday. Of course, over the weekend, I'll do the answer key for this, but so it's going to really depend on you to come Monday with questions. We could do more examples of certain kind of problems. you know, whatever you want to do on Monday. You got to kind of come ready with some suggestions on what you want to do. Here's the stuff, the more recent stuff, right?
Yeah, can you do it 1 like 19? Please.
All right, let's look at this. Yeah, this one. Now, why is this one? I kind of prepped you for this one the other day, like yesterday, I think it was. Some of these are reduced probably. Do you guys see what I'm saying? So this summation notation thing, don't worry about it. First, I want to figure out what the sequence is, and then I can write the summation notation for it, right? So it's like sum up the sequence, but I got to know what the hell the sequence looks like first. So let me do that first. So look at this sequence. Here's something interesting about it is the sign keeps changing. Do you guys see that? Also, so like we said, it seems that it's very possible that these are reduced. Maybe look at every other one. Do you guys see how to maybe rewrite these? No. All right. So you're not, all right. So here's what you're looking for. This isn't necessarily the right answer, but do you see how if I make this one 2/4 and maybe make this one -2/2, do you see how it seems to be going along, but does this last one kind of fit into that? Yes. Do you guys see that? Do you guys see what prompted me to think that way? I saw this is 3, this is 5. And I thought maybe every other one actually reduces because that's how fractions kind of act somehow. Not somehow, but sometimes. That's a little bit weird. I agree. But we saw one the other day where I said, let me be nice. And I wrote it down unreduced. Because if I would have written it down reduced, it would have been a lot harder to figure it out. So there's one that's reduced. Damn you, Jeff. You notice a couple of them have 2's up top. That's another key thing. Maybe they also are supposed to have 2's up top. So let me rewrite everything I see with 2's up top. And then I go, holy shit, all the bottoms are beautiful. They go lockstep. How do I define this crazy ass thing then? Let's take care of, let's write this correctly, Jeff. That'll make this easier.
Is it like 2/n plus 1 or something like that?
All right, let's figure this out. So 2/n plus 1. So if n is 1, that would be 2/2. I'm just missing the negative sign. If n is 2, that's 2/3. If n is 3, that's 2/4. Yeah, so that seems to work for the numbers. How the hell am I going to take care of the alternating signs? This is a neat issue. There's a couple different ways to do this. What's -2 to the first power?
-2.
What's -2 to the second power?
4.
What's -2 to the third power? Do you see how they're alternating signs? So maybe I shouldn't use a 2 though, right? Because I don't want the tops to become different. Maybe I should use a 1. What's -1 to the first power? -1. What's -1 squared? +1, right? So maybe if I do -1 to the n. Anytime you have alternating sequence, you're going to want -1 to the n, or it might have to be -1 to the n plus 1. It depends on, does it start off negative or does it start off positive? Does that make any sense? If I have an alternating sequence, I'm going to have this piece in it. Are you guys out there? Are you guys okay? Does that make sense? You haven't seen that before, that idea, but you know, there it is. Now, if I want to write this in summation notation, let me just throw all this shit inside. Become a +1, there we go. And I start at the first term and I go to what?
-1/3.
No.
Oh, fifth.
These control which term. So first term, second term, third term, fourth term, fifth term. Yes, yes. N means which term. So there's the sequence. And I want to sum up the parts of the sequence, but I only want to sum up from the first term to the fifth term. Does that make sense? Okay, all right. I hope I can take that as a good thing. What kind of sequence is this over here?
Arithmetic.
No.
Recursive.
Recursive. I like it. It's defined by its own terms, right? I'm my own sequence. No, stop it. I'm defined on my own terms. You got to have a seed, which just sounds weird, but too bad. This is called the seed of this sequence. So A1 is 3. A2 would be 3 times A1 minus 4 times 2. Right? Just using the definition. And then you can just continue in that fashion to get the first 5 terms. They're not that difficult. They're basically just function notation. Wah-ha! All right. I think that might be enough for today. What do you guys think? Somebody was ready. Somebody just left right when I said that. Bam, I'm out.
I don't know. Could you give us a wild card problem?
Wild card. What do you mean?
I don't know. Like usually on quizzes, you have like a bonus problem that has like some special thing to it that makes it like kind of out of the box.
I appreciate
problems
that
like that.
You can make one of those up on the spot.
Yeah, that's true. Sorry. Okay.
That's all right. I will definitely have I'll definitely have like 3 bonus questions on here.
On the final?
Yeah. I like
Okay.
to do a few bonus. Anyway, yeah. What could they be? They could be anything. Normally, I like to have at least one of the bonuses, if not 2 of them, be something that's really quick. If you just realize something or notice something or something, and then one of them is just going to be gross, right? Do you know how many questions will be on the test? It's only so which we should focus on which. Oh, good Lord. That's a really good question. Somebody's asking me basically, so no, I'm not going to tell you which sections to focus on. What could be on the final is anything. Every section will be represented to some degree. How's that sound? I don't know. Not every section, every chapter. Be careful. Every chapter will be represented to some degree on the final. Which sections did I notice most students had trouble with? Well, what do you guys think? What do you guys think was the worst concept we dealt with?
Probably like chapter 9.
Oh, let's see. What the hell is chapter 9?
That was like all proving all the identities and stuff like that.
Oh yeah. All right, so trig identities is huge. There's a nice one for you, right? Basically anything to do with trig, normally people don't like. This kind of question I really enjoy because it's polar to rectangular, and then it becomes a conic section problem. Right, so this equation translates into a conic section that you must then identify. That's a yummy problem. I don't know. I can't really tell you. Everybody pretty much had very creative ways to make mistakes on different things. Yeah, the early on stuff was definitely this stuff here. Number 8 kind of beat some people up a bit. Trigonometry and just matrices, just because they can become very tedious. I know they can. I know that. I know it. It's true. I didn't put any inverse stuff on here. I think if I did an inverse problem, it would be a 2x2. Right. Just because it just takes so long to do the inverse for a 3x3 matrix. So I can't put a lot of problems that take a long time on this final, because then I can only ask like 7 questions. There will be roughly 20 something questions. And when I say that, I count A, B, C, D, whatever, right? Because I've had teachers say there's 5 questions and then there's A through J for each one. You're like, dude, that's not 5. Are you a math teacher? Are you sure? Counting should be something up your alley. Well, that's it for the final. Oh, you want more in the final? Dude. I thought you might go back on that. All right. Somebody's like, oh, that's it? And they're like, no, I'm good. All right. Yeah. I said in the 20s, not 20. So in the 20s. So like 25, something around there. So we'll see. And of course, I mean, I could have a problem. Plotting these polar curves takes a while. As you guys have seen, you got to make the XY table or the R theta table. Go to, or parametric curves aren't quite as bad, but they're still kind of bad. I like that problem I gave you guys, the bow tie problem. If you did it, or it's like the bow tie or the 8 or the infinity, right? Did everybody do that? Weehaw. Oh shit, Jeff. There it is, infinity, or it was, I think it was that, and it was shifted one way or the other if you did the quiz. All right, that's enough, guys. That's enough. I'm just kind of rambling now, so that's not very interesting. Anybody need to hang out after here, or is otherwise class is over? It's up to you guys.
Thank you.
Yeah, thank you for the test prep.
All right. And I'll send out an email this weekend with information about next week, how it's going to work with Zoom links and all that kind of stuff.
Okay, thank you.
got
Have
it.
a good weekend.
You too.
Yeah, and it's cameras mandatory and it's 2 hours, right?
That's right.
Got it. Okay, thank you. Bye.